Now, once we decide whether a particular reactant given to us undergoes SN1 reaction or SN2 reaction, then we can easily manage to do any type of the questions, be it road map or word problem or in any form. Now let us see some of the examples of the nucleophilic substitution reactions shown by Rx. We generalize the reaction as Rx plus nucleophile, that is Nu negative. This nucleophile will come from the reagents and forms Rnu plus X negative. Now whether SN1 has to take place or SN2, that we have already seen that what are the conditions for SN1 and what are the conditions for SN2. Now let us see some of the examples of the SN1 or SN2 mechanism or nucleophilic substitution reactions shown by Rx, that is alkyl halides. Now we will be having three things. One is the source of nucleophile, second is the nucleophile, then the product. If suppose the source of nucleophile is H2O, then nucleophile will be OH minus, product formed will be ROH. The next example we can have is, suppose source of nucleophile is KOH, that is potassium hydroxide, nucleophile will be OH minus and product formed again will be ROH, that is alcohols. Third example, we have NaOH is a source of nucleophile, OH minus is again the nucleophile and the product formed is again the same, that is alcohols, ROH. Next we have is ammonia, that is NH3, in which the lone pairs on the nitrogen atom act as a nucleophilic site. So this attacks on the R. Therefore, the nucleophile in this case is the NH2 negative and the product formed is RNH2, which is 1 degree amine. Then we have RNH2 as a source of nucleophile. Nucleophile will be RNH minus and the product formed will be RNHR. Next we have is RNHR as a source of nucleophile. Nucleophile will be RN negative R and product form will be NR3, that is again a amine but a tertiary amine. Now this tertiary amine can also be a source of nucleophile. In this case, the lone pairs on the nitrogen atom again act as a nucleophile, attacks on the R and forms the product as N positive R4 X negative, which is called as quaternary ammonium salt. Next we have is source of nucleophile, that is KCN. Nucleophile will be Cn negative, in which the negative charge is on the carbon atom, not on the nitrogen. Although it can have a charge, that is negative charge, on the nitrogen atom also, but in case of KCN, attack takes place from C negative, not from N negative. Why is it so? We will see it after the examples. Product formed is RCN. The next source of nucleophile we have is AgCN, that is silver cyanide. Nucleophile in this case is the lone pair on the nitrogen atom. So the product formed is RNC, which are known as alkyl isocyanides. Similarly, we have another source of nucleophile as KNO2, that is potassium nitrite. Nucleophile will be O negative N double bond O, and so the product will be RO N double bond O, which is a alkane nitrite. Next source of nucleophile we have is AgNO2. Nucleophile will be the lone pairs on the nitrogen atom, and then the product will be RNO2, which is nitroalkane. Next we have is NaOR, that is sodium alkoxide. In this case the nucleophile is RO negative, and the reaction takes place